So what we're working on now is practical applications of trig functions. So when we're talking about trigonometric modelling, we're applying trig functions, circular functions, to real life situations where things follow the pattern or the waveforms of sine and cosine and so on. So if we have a look at what we've got here, the depth of water in d meters at the end of a pier at time t hours after 6 a.m. is modelled by this particular sine function. Okay, so d is the depth. It's a function of time. Okay, so that's what we mean by d of t. Depth is a function of time. And it's equal to sine pi t over 6 plus 2.5. And there's a series of questions that we're going to answer relating to that. So let's start with question A and work through. Okay, what is the period of the function? So again, we're looking here and we're thinking, okay, how do we normally determine the period? The period is given by 2 pi over n for a sine and cosine function, and our n value is whatever our variable here is being multiplied by. So it's pi t over 6, t is being multiplied by pi over 6. Okay, so our n value is pi over 6. Okay, so we're dividing by a fraction, that'll be the same as 2 pi times 6 over pi. So that'll enable our pi's to cancel, and 2 times 6 is 12. So we can see that our period is 12. How does that relate to this question? Okay, t represents time. So that means the period is 12 hours because time t is in hours. Okay, so it's going through one complete cycle every 12 hours. So that's what it means in terms of this application. Okay, so we can put 12 hours as our period. Part B, what are the maximum and minimum depths of the water? So let's think for a minute about sine function. What is its maximum? So normally for say y equals sine x, what is the maximum and minimum values usually? Okay, usually for that basic function, the max is 1 and the min is -1. Okay, so if we think about this part here has a maximum of 1 and a minimum of -1. So the depth, the maximum and minimum depths would be 1 and -1 plus the 2.5. So the maximum depth is going to be 1 plus 2.5, which is 3.5 meters, because our depth d is in meters. Our minimum depth is going to be our minimum value for sine, so for this function part here, which is -1 plus 2.5. So that's going to be 1.5 meters. Okay. Part C, what is the depth at 7 a.m.? So we're looking for a specific time now. So we need to think back through what we've got here. Our time is t hours after 6 a.m. Okay, so at 7 a.m., then that means our value for t is 1. Okay, so then our depth after 1 hour is going to be sine pi over 6 times 1 plus 2.5. And sine of pi over 6, that's in our exact values table, so that's nice and neat. Sine of pi on 6 is 1/2. So we're working in decimals, so 0.5 plus 2.5, which is going to be 3 meters. Part D. Sketch one cycle of the graph of the function. So we're looking at one cycle which goes over a 12-hour period, because we know our period is 12 hours, so one complete cycle would be for 12 hours. So I'm going to have to make a bit of room here. So, okay, so I've drawn here some axes. Vertical axis is the depth in meters, and our horizontal axis is time in hours. So then, we're doing for one complete cycle. So for t, we're going to 12, and this would be a t value of 0. Okay, now there's no horizontal translation here, so we know for sine that it starts at, normally sine will start there. Okay, now it's going to start at that same point, except we've translated up 2.5 units, so this starting point is going to be up at 2.5. Okay, so let's mark in some scales. So we've got here, now we worked out already, maximum was 3.5 and our minimum was 1.5. So then we can go at our 2.5 mark there, that's where it's actually going to start. And we know that it's going to have a minimum value at 1.5 and a maximum value at 3.5. Okay, so let's get our axes here right. So we've got our halfway point there at 6 hours, divided up completely into 4 to make it easy to work out. All right, so we're going to have our maximum value after 3 hours. Okay, so we're going to reach our maximum of 3.5 after 3 hours, and we're going to reach our minimum value after 9 hours at 1.5. And we're going to be at our halfway point here, here, and again after 12 hours. So that's what we're looking to fill in. So if you can get those points, that makes it easier for sketching. Okay, so sketching that's where we've got our maximum here at 3, minimum at 9, and we're back at our starting point there at 12. Okay, so that's one complete cycle of the function. Part E then, the local council is interested when the depth of the water is at least 3.1 meters. Okay, now 3.1 is going to be somewhere here. Okay, so 3.1 somewhere in here. We want to know when it's at least 3.1 meters. So what's between what two times is it at that point, or above that point really, because it's saying at least 3.1. So from there to there, what is this time period? Okay, so what we need to do then is we need to find out that time. We need to find out that time and then work out what that period of time is. So we're going to let our D value be 3.1. That means that we need to solve the equation 3.1 equals sine pi over 6t plus 2.5. Remember, a trig equation, we need to get this part by itself, so we're going to subtract 2.5. So 3.1 minus 2.5, that's 0.6 equals sine pi over 6t. Okay, now we know that this is not in our exact values table, so we're going to have to work out our basic angle using arc sine, or the inverse sine of 0.6, making sure that it's set on radians. That's 0.6435, is our basic angle. Now, 0.6 here is positive, so for sine, we're looking at solutions in the first and second quadrants. So that means pi over 6t is equal to 0.6435. That's our first quadrant solution. Second quadrant would be pi minus 0.6435. Okay, so it's 0.6435 and pi minus that, which is 2.498. Okay, that's pi on 6t. T, then, we need to divide both of these answers by pi over 6. And that 0.6435 divided by pi over 6. That is 1.23. We'll just round to 2 decimal places. And this one (2.498) divided by pi over 6 is 4.77 to 2 decimal places. Okay. Now, what the question is actually asking is for how long, correct to the nearest minute, okay, during the 12-hour period. So we need to find the difference between these two. So this one here corresponds to this point, and this answer here, 4.77, corresponds to this point. So our time period above 3.1 meters is equal to 4.77 minus 1.23, which is 3.54 hours. Okay, but to the nearest minute. So what we can do is you can actually just press your degrees, minutes, seconds button on your calculator to work that out, or you can go 0.54 times 60, and that'll give you the number of minutes plus the 3 hours. Okay, so if we just go degrees, minutes, second button, actually no, 0.54, yeah, times 60, that's right, which is 3 hours and 32 minutes. Okay, so according to this rule, the amount of time above 3.1 meters will be 3 hours and 32 minutes. Okay, so when you're working through these types of problems, that's essentially what you're looking for. This is a common type of problem, dealing with either waves, tides, all that sort of stuff, other ones as well. But you're looking at getting your graph, often working out specific values, finding times, time periods. So it's a matter of interpreting the graphs correctly. Okay, any problems you have with any of the questions in the textbooks, just shoot me a question and we can go through it, and I can do some videos on those as well. So you will find them challenging, okay? These are the more difficult type when you're actually applying them. So make sure you're doing lots of practice with those.